So we're going to talk about some rules for how to find a definite integral, right? All right. So first of all, the order that you integrate matters in the sense that, take a look at this one. Here you have the integral of f of x, and these went away. Okay. Okay. So take a look at the boundaries here. This is going from b to a, right? So we're integrating from b to a, and it equals, look at this one, it goes from a to b. So you see what happened is the limits changed. One is going from a to b, and then the other one is going from b to a. When you swap the limits, the boundaries like that, you have to multiply it with a negative. Okay? So for example, if you're trying to find the integral from 3 to 0 of x squared dx, that's going to equal to the negative of the integral from 0 to 3 of x squared dx. Okay? The difference is, because a lot of these can also represent, for example, direction, right? Like it could be, for example, the area under the curve could be displacement, right? In which case, like the direction will matter. So it matters between, like if you're going from left to right or right to left, okay? Also, it's convention that we always put the bigger number on top here. Okay? Yes. Find the integral of f of x dx. Now remember, integral is area. From a to a, right? Well, how much area is enclosed? 0. So that'll just be 0. So for example, the integral from 2 to 2 of sine x dx is just 0. Okay? All right. Here's, yeah. No, because no matter what your function is, if you're finding the integral or the area from 2 to 2, like there's no point. Yeah, there is no area for you to find. Okay, how about if you have a constant multiple? When you have a constant multiple, you could just take out that constant. So for example, if you have a k here, you can take it out and put it outside for any number k. So for example, if you have, for example, 0 to 2, 4x squared dx, that's the same as 4 times, so you can pull out the constant, and then you could just do 0 to 2 x squared dx. Okay, and then whatever you get for the area for the integral, just multiply it by 4. Okay? All right. Sum and difference. Let's talk about this for a minute. This should have parentheses around it like that. So suppose you want to find the area from a to b, the integral from a to b of f of x plus g of x. You could split it up. You could find the area for f of x separately. You could find the area for g of x separately and then add them to each other. All right? What do I mean by that? Suppose you had to find the integral from negative 2 to 2 of x squared plus 4 dx. Well, you could do it like this. Negative 2 to 2 of x squared dx plus negative 2 to 2, 4 dx. Okay? Just like, remember when we used to take derivatives like back in the olden days, right? And you had like x squared plus 5x plus 7. You did each term separately. Same deal. Okay? Okay. Now, take a look at what this next one says. We're taking the integral of f of x. We're taking the integral of f of x. But look, this goes from a to b. And the second one goes from b to c. So essentially, what you're doing is, look at this. You have, yeah. Here's A, B, and C. So the first one is telling you to find the area from A to B. The second one is telling you to find the area from B to C, or you could just find the area straight from A to C, right? It's in geometry, it's not the transitive. You have like segment addition property and then angle addition property. Not the transitive property.
Can that only be done if the function is the same on both sides?
Huh?
Can that only be done?
Transitive properties, if A equals B and B equals C, then A equals C.
No, I mean that one's from A to B and it's a function f of x. That one's from B to C, it's function f of x, so it works. But if it was f of x and g of x, you couldn't.
Yeah, no. Right. So Elliot brings up a good point that obviously this is going to work only when like you're integrating the same function, f of x, right? So again, so an example is if you have, for example, okay, so let's go backward. Suppose you have to find 0 to 5 of f of x dx. You could also, if you wanted, you could split it up. You could do 0 to 3 f of x dx plus what f of x dx? 3 to 5. Right? And look, here, isn't that sort of like what we were, like we could have done that here too, right? Like if you have to find the area under something, and let's say it's a trapezoid and a rectangle, you could split it up. You could find the trapezoid, you could find the rectangle, and then add them. Okay?
Can you make it a little bit bigger?
Yeah. Is that okay?
Wait, so what's the purpose of doing that one?
The purpose is when you come across some complicated functions, you know,
Like the one on the
you could split them up.
Like the one on the test that had.
Precisely. Yeah. And then you'll see that it has its benefits algebraically as well. So, yeah. Yeah. In math, there are always 3 ways to solve anything, like 3 ways to go about things. And that's graphically, algebraically, and numerically. So last couple of sections, we showed you how to find the integral graphically, right? Now we're going to do it algebraically. And then numerically, that's just like plugging in numbers. We're going to skip that part. Okay?
Is that the easiest?
No, it's the most, what's the word? Tedious. Okay? Yep. All right, I don't know where these parentheses go. I actually do know where they go, and it's the way we type these up. Okay. So let's do these. We're going to use some of this stuff here. So you're given that f of x dx from -1 to 1 is 5. From 1 to 4, f of x dx is -2. So notice how these are both f of x. And then you have h of x's, right? So these are separate. And again, the ones in the red, you have one that goes from -1 to 1, and then you have one that goes from -1 to 5, right? The one in the blue, it goes from -1 to 1, and then continues from 1 to 4. All right. Right, so we have to find the ones that are given, and like these are like some of my favorite things to do. So you have to solve these based on what you're given in the blue and the red, right? So take a look at this one. They're so cool. They're like little like puzzles. So look, now we want. Well, you know, it's they're different categories. There's like mind-blowing things. And then these are just like super fun things that you could just do to pass the time. This is super fun to pass the time.
On the bus or something.
On the bus or on a plane. Yeah, right? Like 11th graders when you go on your South trip. Like when I teach 10th graders, I tell them all the time, when you're going to Israel on SIEP or EIEP, you could totally do this stuff on the plane. There must be a song like that. Okay. So look, I have to find the integral from 4 to 1 of f of x. What am I given? I'm given the integral from 1 to 4 of f of x. So in going from 1 to 4 to 4 to 1, what is it that I have to do? It's the negative. So it's the -1 to 4 of f of x dx. So that's just -2, +2. Okay? You see how here we're told that the integral from 1 to 4 f of x dx is negative 2? So now we need the negative of this. So it's negative 2.
So how can the 1 and the 4 just switch
Look for what property.
Well, because you're given 1 to 4.
Okay.
Now, can you use some of the rules to find 4 to 1? Well, the first rule we learned was if everything is the same, but you just swap the boundaries, you just have to put a negative in front.
Okay.
Okay? All right. So take a look at this one. We have from negative 1 to 4 of f of x dx. Well, look at the blue. I don't have any of that stuff. What do I have, though? I have from negative 1 to 1 f of x dx plus 1 to 4 f of x dx, right?
It's like a puzzle.
It is like a puzzle. So now you have 5 minus 2, 3.
Wait, so, sorry. For this one that we just did, I'm kind of confused how.
So this
how
one,
did you decide to use one of it?
let's think about area. You need to find the area from negative 1 to 4. The integral from negative 1 to 4. Here I'm given the integral from negative 1 to 1. And then from 1 to 4. Right? So
You're really going from negative 1 to 4. Oh, I get
Yeah.
it. Yes, I totally just did it.
So look, this goes from negative 1 to 1. And then this goes from 1 to 4.
Okay, so you're just trying to make them match.
You're just trying to make them match.
Oh, that's nice.
Yeah.
Why did you subtract? Why did you 5 minus 2 instead of 5 plus 2?
Because the value of this is 5 plus the value of this is negative 2.
Oh, I didn't see. Okay, I thought it was 2. It's negative. I thought it was 2 was the last problem. Yeah, 2.
Okay, so take a look at this one. I have negative 1 to 1 f of x plus h of x. I can totally split those up. Negative 1 to 1 f of x dx plus negative 1 to 1 h of x dx. So am I given a value for negative 1 to 1 f of x dx? What is it? 5. Am I given a value for this? 7, 12. Okay. All right. From 0 to 1, f of x dx. So let's look at our f of x's. Those are the ones in the blue. I have negative 1 to 1, and then I have 1 to 4. Now I need 0 to 1. So what do you think?
You could like go
Negative
into
1
1
and then subtract 1.
No, maybe you could go with the 1 and 4, and then you know it's like negative 2, and you can like divide.
Divide it by 2.
Well, okay, you would divide it by 2 if you were sure that the area here was symmetric so that you could divide it by 2. What if the area isn't symmetric? What if from negative 1 to 1 this function is something like that? So like it's not, so you have not enough information.
Right.
Okay?
I don't get how
Yeah.
No solution always works.
Except for when it's not.
Is it no
Oh my god,
solution?
this answer.
What are you doing with the answer?
It's not enough info. So let's take a look at what we're given for h of x. For h of x, we're given negative 1 to 1. And then we're given negative 1 to 5.
Oh, you just subtract them. Yeah.
Right? So 1 to 5, you just have to subtract them. Right? Okay, so it's going to be 1 to 5, h of x dx is equal to negative 1 to 5, h of x dx minus negative 1 to 1, h of x dx. Okay.
Wait, no, wait. Why? But which one is 1 to 5? There's nothing like, actually 1 to 5.
Right.
But when you have to flip the second one to make it negative,
So
you're just subtracting this. How do you like? But like, what do you? Why do you do both?
If you draw it, it makes sense.
So look, the first one tells you the area from negative 1 to 1, this much. The second one tells you the area from -1 to 5. What I want is this balance here.
Okay.
So you have to subtract the blue minus the purple. So -1 to 5 minus -1 to 1.
Okay.
Okay? And -1 to 5 is 12 minus 7. That's just 5. Okay. Next, I have -1 to 1. I'm going to split these up. 3f of x dx minus -1 to 1 h of x dx. And what can I do about the 3?
Put it on the outside.
Put it on the outside. So 3 times -1 to 1 f of x dx minus -1 to 1 h of x dx. And we plug these in. So you have 3 times. What do you get for the first one?
15.
Is it 5?
Well, 3 times 5.
Minus 7.
Minus how much?
7.
7. 50 minus 7, 8. Okay. One very important thing. If you forget to put the dx every time you have an integral, there will be points taken off, because having this symbol alone means nothing. Those two go together, all right? Because it's the sum of all of the areas, right? It's the sum of all of the little dx's. Listen, remember what this was? F of x dx. Remember where this came from. This was area of a rectangle. So it was base, or this was the base and this was the height, right? So if you omit the dx, then you're just adding up the heights of the rectangles, and that means nothing. That's meaningless. That's not area. That's just adding different lengths. So you have to add. So you have to do the height times the base. The height times the base. Does that make sense? It's mathematically wrong. Like there is no way to justify it. Okay? And me, as a math teacher, there is no way I could justify it. So, don't forget the dx's. Okay? I know in the beginning it'll take some practice, but keep writing it and don't miss them. Don't miss writing them. Okay, so this was in 5.3. Now, the book does this and then sort of like leaves us hanging, and then it picks it up again in section 6.2. But when they do this in section 6.2, it's totally misplaced. So we're doing it now. Okay? Yeah, it's there. It should have been here. Somehow the author thought he could just put it there. I mean, it's like, I don't know. I actually am. This is the plan, yeah, because I've had it up to here.
No, are you actually gonna write on that? Maybe such a good math.
Thing we're also doing when we find an integral, yes, it's area. We're also doing the opposite of taking a derivative. And since opposite, another term for opposite is anti, the opposite of a derivative is the antiderivative.
I talked about this.
Yes.
That's not.
So,
Oh, you told me to talk about this.
so
They're like, have you learned about antiderivatives? I was like, no.
the antiderivative is denoted by f of x dx. So now, stay with me here for a minute. Suppose there is a function f of x, and you find the derivative of that function f of x. And you know what? Let's just do that to get comfortable with the terms. Suppose f of x is 3x squared plus 6x. And if I were to take the derivative of this, what would I?
6x plus 6.
Right, 6x plus 6. Now, suppose instead of calling this f prime of x, I called it capital F of x. I could do that, right? Instead of calling it f prime, I'm just going to call it big F, because my keyboard doesn't have the accent key or whatever, right? So let's just get used to that notation. And then I could even, if I wanted to, call it that, right? Yeah. So suppose f prime of x is a function, right? Now, then, if I took the integral, then I would get f of x plus c.
Which is the integral
Okay.
of what?
Right.
The derivative.
Right.
Okay.
Okay?
Cool.
So now, we're going to come back to this when we do section 5.4. Okay. These are, all right, so now, remember I just showed you all of those rules of integration? Well, actually, I could just do them here. Remember I just showed you the rules of integration before? Here is 2 of them. This is the constant and the additive property, right? Now, here are some power formulas. Okay? Now, if you have to take an integral of u to the n du, here's what you do. It's u n plus 1 over n plus 1. Okay, what does that mean? You have f of x, and it's x to the 4, right? How do you take a derivative of this? The derivative would be the 4 comes down, and what happens to the x? You subtract, minus 1.
No, so it'd be yeah.
Now, if you were to do that in the reverse direction, instead of subtracting 1, what would we do? You just add 1 to make it a 4. And then how would you get rid of the 4 though? You just divide it by that number. Okay? So let's do that again. Let's do that again. Suppose f of x is equal to x to the 6. What's f prime of x going to be? 6x to the 5th. 6x to the 5th. Now, if I wanted to go backwards, right? If I wanted to go backwards, what would I have to do? I subtracted, so now I need to add 1 and divide by 6. That's so cool. It's 6x to the 6 over 6, which is just x. Okay, so what would that be? 6x to the 6 over 6. What do I get back? X to the 6. You see that? So you just have to undo what you did.
What do you do when there are trig functions?
Oh, well, there are rules. Okay, now, when we had to take the derivative of, when we had to take the derivative of ln of x, what did we get? 1 over x. So now, if I need to go backwards, every time I see 1 over x, I just do ln of x. You just have to remember that. Okay? E to the x is e to the x. Right. So we just learned the power formula. So take a look at this one then. If you have the integral of u to the minus 1, that's the same as the integral of 1 over u du. That's just ln of u plus c. Now, what the heck is this plus c business everywhere? For now, just put plus c everywhere. Okay?
What is the x to the 6 plus
I'll tell you, though. It's not a secret. I'll tell you. Okay? All right. So here's why you need the plus c. See, this is why math is fantastic. Okay, so look. Okay. So look. My integral, right? Suppose I have x to the 4, right? And I want to get it back to the function. What did I say I have to do? So if I have integral of x to the 4 dx, what did I say I had to do? It's going to be x to the 5 over 5. Right?
That's right. And then you put n there.
Right. So now take a look at this one. Let me take a derivative of this, right? If I take a derivative of that, what do I get? 5x to the 4 over 5, which is x to the 4. I'm taking a derivative now. Mm-hmm.
It should be 5x to the 5th over 5?
No, that was like when we were going backwards.
Oh,
Okay? So now, suppose I had x to the 5th over 5 plus 3. Now let's take a derivative. What would I get? Here I get 5x to the 4 over 5 plus 0. So I get x to the 4. So look, I got x to the 4, x to the 4. What if I have x to the 5 over 5 minus 2? What am I going to get? That's still going to be x to the 4. So that means if taking an integral, if it means find the function from which it came, there could be a whole series of functions from where that came. All right? So that's why we have the plus c. Okay, trig formulas. You just have to remember these. So remember when the derivative of sine is cosine? The integral of cosine is sine. It now goes backwards. Derivative of sine is cosine, right? So then the integral of cosine is sine. You have to do the opposite, remember? Okay, what's the derivative of cosine? Negative sine.
That's going to be the
So
derivative
then
of negative sine.
the
Sine on the
integral
sine
of
is
sine
negative
is
cosine.
negative cosine.
So integrals and derivatives are like
Yeah,
And
they're
then what was it-
reversed.
and then the derivative of negative cosine would be positive sine.
Huh?
What's the derivative of negative cosine? It'd be-
The derivative of negative cosine is negative sine,
and then the derivative of negative sine.
is positive cosine. Yeah,
Jesus.
I'm just having trouble with one thing.
yeah.
The plus c, if we're doing that, let's say a homework test, whatever, how are we supposed to find that c? Is there anything
You don't find the c, you just say plus c.
just plus c?
Yeah. Okay. Okay. So let's, and then in cosecant squared is negative cotangent and so on. So if you look at these going in the reverse direction, you'll be able to match them up with the derivatives, right? The derivative was the derivative of tangent was secant squared, right? The derivative of cotangent was negative cosecant squared, so there is a negative there and so on. Now, what about exponential and logarithmic functions? So the derivative of e to the x is e to the x, so the integral is the same. Okay. The derivative of the integral of ln of u, this is a new one that you have to refer to. Okay? Yes, I give you that. Let's do a couple and let's try to see how much of it we can break down. Okay?
We have to memorize all of this. Do you have any like
Most of them. So let's do this one. All right, so we need to take an integral of x squared dx, right? This is a power rule, right?
bring down the two? Oh, so is it just that divided?
So it would be 2x.
So it's going to be x to the power of 2 plus 1, which is what? 3, divided by 3 plus c.
And then that's it. That's
Yeah, that's it. So that's going to be x cubed over 3 plus c.
It's a y plus c.
Like what? Yeah.
represents like a value like 1, 2, 3.
The reason, that's what I was trying to show you guys here is if we take a derivative of this, we're supposed to get the original function back, right?
Yeah.
Okay, so if I took a derivative of this, x cubed over 3, or if it was x cubed over 3 plus 4, plus 7, minus 2, when you take a derivative, that goes away. So there could be multiple functions that give you that function back.
So this
Okay.
basically is just constant.
It's a constant. So, in another, if I had, let's say I had x to the 5, x to the 5 plus 2, x to the 5 plus 7, right? What's the derivative of the first one? 5x to the 4. What about this one? 5x to the 4. What about this one? 5x to the 4, right? So if you integrate then, now if you integrate 5x to the 4, how do you know if it came from x to the 5 plus 7, or x to the 5 plus 2, or just x to the 5. You don't know. That's the reason. Okay, so look at this one. Integral of 2 cosine x dx. So there is a 2. And what's the integral of cosine? Just a positive sign, right? Plus c.
It'd be 2 plus 2 sine.
Not the product rule. The product rule would be if you had two different functions multiplied by each other. The ones now, yeah, the ones now, that's a whole other ball game. We're not going to do that just yet. Yeah.
How is the antiderivative the area under the isn't that what
Because we're doing indefinite now. If we were doing definite, you could do, huh?
Why isn't it a negative?
Well, what's the derivative of sine?
Negative, cosine.
Just cosine. So think, if you were to go back, how would it work? It's the opposite. It's in reverse.
Cosine is,
Okay?
cosine, wait, cosine, so the derivative of wait, so the second thing you have is the cosine, so it would just be sine.
Right.
The sine is cosine.
Right.
The derivative is
Right.
backwards.
Right. Yeah, that's all it is. So, the integral of e to the x is e to the x plus c.
Sorry. Well, unless you have a chain rule.
The derivative of e to the x is e to the x. So the integral of e to the x is e to the x plus c, always. Again, if you don't have the plus c's, you cannot get full credit. Okay? All right, so this one here, we're going to use the rule where you could split them up. So we're going to do each one separately. So let's just do this one first. Divide and conquer. So just that one will be 2x, add 1, divide by the result. That's it. Now here's how I do the next one. Just this. Minus 3x, add 1 to the exponent, divide by the result. Now the next one. Plus 8x, add 1 to the exponent, divide by the result. And if you say it enough times, add 1 to the exponent, divide by the result, it minimizes your chances of error. So one more time. Plus 4. What's the exponent of the x in that case?
0.
It's 0 now, so it's going to become 1. X to the 1 divided by 1. Or you obviously don't have to divide by 1. Plus c. So we simplify. X to the 4 over 2 minus x cubed, 4x squared, 4x plus c. Now, if you wanted a way to check your work, what would you do? Find the derivative and you should get the same thing back. And what will happen to the c? It'll go away, right? Because that's a constant and the derivative of the c is just 0. Okay? So here we're going to get 2x cubed minus 3x squared plus 8x plus 4x. That's it, plus 4. Okay? It's reverse. It's an antiderivative. So, what do we get for the first one?
3x plus 1.
3e to the x. That's it, 3e to the x. Right? E to the x just gives you e to the x back. Plus, what about for the next one? 2x plus
C.
that's it.
Wait, again.
Yeah.
For the one on the plus 5 never mind.
By the way, the plus c is a capital C. It's a thing. Don't give me lowercase c's. Okay.
Would
you really be able to tell?
Yeah, it's kind of.
Like you give small rating.
Like, I have really long handwriting.
I mean,
I feel like we can debate that one.
like super big. Like,
okay.
Whole page.
Now, 6x we know how to deal with. Root x, I never told you how to deal with it, but I did tell you how to deal with powers. So it's x to the 1/2 dx. So then this is going to be 6x squared over 2 minus x to the what? 3 over 2 divided by 3 over 2, which is what? Well, hang on. It's plus c. What I meant was, so this is 3x squared minus, what happens to that 3 over 2?
No, you multiply it.
Comes
You
up.
multiply that by 3 over
Okay. So anytime you have something divided by a fraction, it's the reciprocal of the fraction times the something. Okay? Divide by 2 over 3, multiply by 3 over 2. And you'll know later that if like whatever the exponent is here, you'll just know later to multiply it by the reciprocal of the exponent. Okay. What about x to the negative 2 then?
To add 1 to negative 1.
Uh-huh.
Negative 1 over negative 1.
Plus c. So it's negative 1 over x plus c. Don't give me any negative exponents in your answer. That is a thing of the past.
Wait, how did you change x to negative 1 over negative 1 to negative 1 over x?
Okay, so the negative one, that's just a negative, right? So this is another way of writing this, right? Because if you divide by negative 1, it's just a negative. And then, anytime you have a negative exponent, it's just 1 over x. Okay, so what about the next one? Cosine x plus c, that's it.
What about the negative?
Well, negative, sine x is already negative.
Then
Oh,
think.
negative side.
Yeah. Okay, so what about the next one? Plus x to the
Nope, just kidding.
1/3.
negative 2/3 plus 1 is 1/3
Divided by 1/3.
divided by 1/3 dx. Now, oh, sorry, plus c. Now, if you wanted to do it,
It'd be 3x to the 1/3.
thank you. All right, so go ahead and do the next one then. Okay, ready?
Wait, what is that? Does it say 8?
8 over 3 times x to the 3 over 2 plus c.